A robot failure rarely arrives as one clean exception. Navigation, transforms, sensors, and lifecycle nodes can emit hundreds of interleaved messages before the system finally stops. ROS-Trace AI turns that noise into an evidence-backed incident timeline and practical next steps. The core experience works offline. It needs no robot, no ROS installation, and no API key. I will load the bundled navigation failure and run the deterministic analyzer. The parser recognizes common ROS1 and ROS2 log formats, tolerates malformed lines, counts severity, and groups repeated failures instead of flooding the report. The result highlights 4 connected incidents. A transform timestamp falls outside the TF buffer. A required velocity topic has no publisher. An action server times out. Finally, a controller process exits unexpectedly. Every hypothesis includes the exact source lines and a concrete diagnostic action, such as inspecting the transform tree or checking topic publishers. The tool narrows the search without pretending that a hypothesis is certainty. Codex was the engineering partner for this project. It helped define behavior before implementation, separate parsing, diagnosis, model access, the API, and the interface into testable layers, and keep the judging path to one fast API process with a bundled sample. Automated tests cover malformed logs, repeated errors, offline fallback, and API behavior. GPT 5.6 has a focused, optional runtime role. When enrichment is enabled, it receives the structured deterministic findings and improves prioritization and explanation. It does not replace parsing, and it is not a single point of failure. Without credentials or connectivity, the offline report remains fully useful. The public repository includes the MIT license, sample data, setup instructions, and automated tests. Clone the project, run UV sync, start the fast API application, and load the sample. ROS-Trace AI turns noisy robot logs into evidence you can act on.